So thanks everyone for joining us. Obviously, a massive thanks to Emily as well for talking to the group. So a few words, a bit of background, and a bit of a call for help. For those of you that don't know me, my name is Barry Cranford. I'm the founder of the London Java community. So I'm not a developer myself. I run a tech recruitment company called RecWorks. So at RecWorks, we've been on a mission for about the last 12 years to prove that recruitment can be a force for good in the tech industry beyond just getting people jobs. And that's specifically around learning, mentoring, career development, and that kind of thing. So put simply, if people want to learn and people are happy to share or teach, then we're happy to draw the lines between the two. And that can be on a group basis like today, or on a one-to-one level. So the Meet and Mentor community is probably the best example of what we do. It's got very close links with the LJC. We've made over 2,500 personal one-to-one directions there, and introductions there. And we've got about 1,700 members. So it's all on a personal basis. It's not automated. It's all done through Helen. So if you're interested, please sign up. But we are always looking for more members and more mentors, people that can help mentor anyone from students to junior CTOs and aspiring speakers and that kind of thing. If you're interested, then look us up on LinkedIn or meetandmentor.co.uk or come and have a chat with me afterwards. It's all powered by revenue from recruitment. So we don't make any money from anything that we do other than getting people jobs. So if you're looking to hire, then please do bear us in mind. Anyway, on to today. I'm actually going to hand over now to my co-host, Bruno Bassola, who is a member of Meet and Mentor, and he's going to introduce our speaker, Emily. Thank you.
Hello, thank you, Barry. It's my pleasure to introduce Emily. Emily is a Java champion, and I met her the first time, I think, at GCon at the conference, and she's an amazing speaker first. She also is a guru in MicroProfile, and I think that's the reason why we have her here. So she led the specification of MicroProfile Config, fault tolerance, and service mesh. And I mean, and she's also, again, an amazing speaker. So I think that sums it up. And I'm really honored to be here to introduce her. And I will leave it to you, Emily, and thanks a lot for your time today.
Yeah, great. Thank you for giving me the space for me to tell others, about this cloud native microservice programming model, MicroProfile. Okay, let's get started. I have a lot of materials to go through. I'm wondering, actually, is how good to launch a chat. So it's actually, I would like to ask you a question, like how many of you have heard of MicroProfile? So in the chat window, you can say yes or no. So this is the kind of would be interesting to know. I mean, how well known MicroProfile is. So that will set kind of foundation. Okay. Oh, that's good. It's kind of most people have not heard of it. Some of them have heard of it. Okay, in today's session, hopefully for the ones who have not heard of MicroProfile, you will be able to learn the kind of all the concepts of MicroProfile, the capabilities and etc. And for the ones who has already heard of MicroProfile, hopefully I give you a big the update on what MicroProfile currently is doing and etc. and all the specifications, and then put in the concept about why and how and what MicroProfile can do for your cloud native microservices. Okay, let's get started. By the way, I work for IBM, so I'm a senior technical staff member. So as Bruno already said, I mainly spend the time working on the MicroProfile and also Open Liberty. Both are open source. So I'm very keen on the open source community. I think strongly believe that's kind of the the new trend. So more and more companies and are trying to do open source. This is a great way forward for the future development. So we should all go out to collaborate, contribute, and learn from each other. Okay, thank you all for your quick response. So it's in today's session, I talk about cloud native microservices, and also in the concept like why the kind of microprofile can help. And also, I especially talk about Java microservices. And as you probably you already know, Java is still the #1 or #2 programming language in the IT industry. So Java is going going strong, and is kind of, because Oracle currently doing all the kind of fast-paced release, I think is attract a lot more developers. And also Java has a really good ecosystem. So other programming language is quite a difficult match with Java. So in today's session, talk about Java-based microservices, and also is in the concept of cloud. Okay, so when I talk about cloud, so what cloud demand? Actually, the cloud, whenever you think about cloud, you should thinking about every space, every second, millisecond, you are there running in the cloud, you need to spend the money. So if you consider going to the cloud, you need to make sure you have a really small, tiny, application, just enough application. And your application is really fast. When it's not running, and you should not consume any resources. So in this way, you are not wasting your money. So this is what cloud native means. So it's as I laid the foundation is Java-based microservices. So it will be the next thing is the Java. So what requirement on the Java in the cloud? So we need a Java is a very small footprint and fast. And this is the JVM. We need really a small JVM and very fast JVM. So we compared different JVMs. As if you have not heard or adopt OpenJDK, you should check it out. That's an amazing open source project. So it's it has many JVMs. So we compared two popular one, Hotspot and OpenG9. And we found out OpenG9, the memory footprint is 60% smaller. And also the startup is 30% faster with this share classes and quick startup. So if you have not tried OpenG9, have a go and try it out. So this is the open source projects under Eclipse Foundation. So it's what you can run is with the JVM chosen. What you can run sometimes can outweigh the JVM benefit. So in order to make a best use of JVM, and you also need to make sure you have a really good structure for your cloud native microservices. So your microservices need to be RESTful. So basically it's kind of stateless. It should be like a cat or pet, because it should grow, can be duplicated, and also can scale down. And when is like a low demand, it should shrink. It's like a less instance. And also it should be communicative, so that other microservices be able to interact with it. and also can this microservice can communicate with the cloud infrastructure. And also it should be configurable. So once you write this microservice, you can configure in the cloud infrastructure, in the environment, etc. So written once, configure everywhere. The third one is your microservice should be resilient. So basically it can behave under whatever the situation is. If the backend not responding, your microservice should still react as normal. So basically you need to be a fault tolerant. So the fourth one is your microservice should be discovered. Once you talk about microservices, and there will be many microservices. So you need to find out what this microservice can do, and etc. And also is when you talk about microservices, and also, sorry, let me. Sorry about that. So it's the next one is the microservice need to be secure. Basically, it's this if you have many microservices, some microservices might contain very sensitive kind of information, such as salary check. That's a kind of function. You don't want any arbitrary people check other people's salary and etc. So this is secure. The next one is traceable and monitorable. So basically, is when there's many microservices, if something goes wrong, it's really hard to find out which one is not behaving. So you need to this trace facility, so it's traceable. And also, you need to monitor this microservice. So sometimes you say, okay, this microservice is under load. And under that kind of circumstances, you might want to scale up microservice. Or one microservice probably is kind of going to die any minute time, and you might need to do some recovery plan, etc. The final one is your microservice should be intelligent. It should be able to communicate with the cloud infrastructure and tell the cloud when your microservice is ready to serve request, and when your microservice maybe is going to die. Basically, it cannot survive anymore. At this time, cloud infrastructure can kill this microservice and restart it. Like this is kind of the quality of service microservice. And if you have, read all these kind of requirements, etc., you are thinking, okay, so actually you are paid for the writing the business logic, right? And all these kind of quality service is overwhelming. Is if you need to fulfill all this, you spend most of the time to fulfill this quality service instead of doing any single line the business logic, which is not you are paying for what you are paying for. So luckily, luckily MicroProfile is here to help you to fulfill all these kind of quality of service. So MicroProfile, I will keep it very short, is community driven, is open source projects, is established 4 years ago by IBM, Red Hat, Tommy Choi, Piara, London Java community. Actually, the London Java community was one of the original founder as well. So here we are. And also later on, like SuJava, Hazelcast, Cumulus EE, Fujitsu, Hammock, Microsoft, Oracle, they all joined. So this is a huge collaboration, and also it has very lightweight iterative process. So we're aiming to do 3 releases per year. So this is unheard of it in Java EE history. And always the spec, API, TCK, freely available. So there's many implementations of MicroProfile. As you can see here, it's about 1,000 implementations. IBM, we have Open Liberty and also repackaged with WebSphere Liberty. Red Hat, Quarkus, Wildfly, Sontail. Sontail is going to go auto, going to be replaced, going to be being auto service soon. So Red Hat has a Quarkus and Wildfly, and Payara has Payara, and Tommy Tribe has Tommy. Oracle has Halidon, and also Fujitsu has Apache Launcher. Cumulus EE has Cumulus EE, and also Prana and Hammock. So it's so this is the link is kind of tell you what the runtime implement. Basically, it's not all the runtime implement all the kind of specifications. Some runtime implement part of the specification, but Open Liberty is and also Open Liberty is very keen with MicroProfile, so it's kind of follow MicroProfile very closely. So we try to implement all the MicroProfile specifications. So this is the full picture of the MicroProfile. Like 4 years ago, we adopted CDI, JAX-RS, and JSON-P from Java EE. And then when JSON-B was announced in the Java EE, and also we adopted JSON-B. So basically, these red blocks directly from Java EE, or nowadays we call it Jakarta EE, and all these 8 specifications and directly created in the MicroProfile community. As Bruno mentioned, actually I personally lead the config, like a specification and also fault tolerance. Config is the first MicroProfile specification. So I started this config specification, and then had to work out how to release the MicroProfile specifications. So it's kind of, this is more like a guinea pig, and try out and also try out a release process and establish best practices and etc. And then it's all the rest specifications follow a similar pattern established by config. So this is all in the MicroProfile umbrella release. However, here we have a standalone release. So context propagation, reactive messaging, reactive stream operators, GraphQL. These are all released in the past couple of years. They are standalone because we want to release it and test it out to see whether the end user have any feedback and etc. And tell us how good it is. And then we can consider whether to merge into this umbrella release or not. And at the moment, this one is gray. So this is long-running actions. So this is established a pattern about how to do transactions in your microservices. Basically, this one based on the kind of Saga pattern. So it's kind of eventual data consistency pattern. So this is long-running actions. So in this, in the next probably half an hour, I will go through this 8 specifications. This is a whole 12 specifications. In more detail, tell you what they are, how do you use it, etc. So it's let's step back and to say how can you create your microservice. Actually, microservice is not that difficult. It's really simple. For the ones who do not know microservice, microservice is nothing except a service. So it can expose an endpoint. So you can use JAX-RS to create your first microservice. Basically, you can just have 2 classes. One is the application class. The other one is the JAX-RS resources. So it's so here the JAX-RS resources like this get operation is a JSON object, and then there's on the wire type is a JSON. So basically, this will expose endpoint /system/property. So this is JAX is here to help you to create a RESTful microservice. So the next thing is once you have these two classes, and then your microservice need to do some business logic, right? And then you it might be sometimes complicated. How can you tidy it up? How can you create a very loosely coupled microservice? So the programming model we use is CDI. CDI stands for context and dependency injection. If you know Spring is alternative to Spring like an injection, so inversion or control. So CDI has one a very well-known annotation, which is @inject. So this is equivalent to Spring auto-wired. See, if you know Spring, now will be auto-wired. So this is @inject. Actually, @inject is directly from JSR 330. CDI adopt JSR, implement JSR 330. So once you know this annotation, once you use CDI, you will not call the constructor anymore. You directly say @inject system client. So the CDI container automatically create an instance and assign to this instance. So you don't need to say new up the constructor and etc. So the next one is the payload format. So the once you create one microservice, and then you other microservice will communicate with this microservice. So it's they will transfer some information on the wire. So in what kind of format then? So the popular format will be JSON format. In order to help, sorry.
Yeah, the speaker will be back soon.
Sorry, I just have sorry, I just have a glitch here. So it's so here is the you need to use the JSON-B and JSON-P to help you to create the JSON median type. So basically, in this example here, the type, so the type here is the median type application JSON. You have an inventory list. So you can directly create a class inventory list, and then the JSON-B implementation automatically and convert the object of this into a JSON format. So basically, it can serialize into a JSON object. On the back to the client bit, and it can deserialize it and into the object, into the the inventory list object. So the next thing is how can you once you create one microservice, and also you specify the median the type and etc. The next one is connecting microservices. How can you connect this microservice? How can you make a microservice A directly call into microservice B? So MicroProfile REST client, that basically is all of my slide here. We will have a Git repo. If you want to know more about the any particular specification, you can click on this link. So basically, this scenario is the 1A call B. So however, when A call B, I know A need to invoke B's interface, B's endpoint and etc. So in what can I do with it? So it's in A, microservice A, you directly like a duplicate this interface. Basically, this is the kind of, for example, B has the get properties, this operation, and it's a get operation and produce application JSON and returns properties. And then in A, you duplicate this, you create this interface, and then you add a register REST client. And then in A's JAX resources, you directly inject at REST client. So the MicroProfile REST client implementation sees this one, registers REST client. It will create an instance of this system client. And then when you do the inject, it will give you that instance. So this is default REST client. You can call default REST client get properties, and it will call microservice B. And then you are thinking, okay, with this too, how can you know where B lives? That's a really good question. So how to wire them up? Actually, we use config. So here we can use fully qualified class name, here, system client, fully qualified class name, and then /mprest/URL, and then you put a B's endpoint here. So when you call this default REST client get properties, and then is you automatically forward to localhost 9080/system. So that's how it works. Later on, I can show you some code. So the next one is documenting microservices. So this is kind of one of the quality service. You want to document this microservice to say, okay, this microservices have this endpoint, what this endpoint is for. So this is the documentation. So MicroProfile Open API directly adopts Swagger API. So Swagger API. So basically, it's if you know Swagger, this is the Open API response. If you do like a MicroProfile Open API, automatically exposed endpoint, host and port / Open API. This is the output of this Open API. To describe how many endpoints do you have for each endpoint. I mean, what kind of operation you have, like this one, the pass inventory systems, and then the get operation, and the summary description, and also is kind of have a parameter, and also has the if the response 200, what it means, and etc. So this is kind of, this is get operation. This is the method and method name list content. And this is the response. This will be a 200, what is for, and then this is a schema. So in Open Liberty, we also have another endpoint /UI, so you can visually see all the endpoint you have. You can invoke any particular UI as well, any particular endpoint as well. So that's the Swagger. If you know Swagger, you will know MicroProfile Open API. So the next one is secure microservice. How can you like a secure microservice? We use MicroProfile JWT together with Java EE security. So basically, MicroProfile JWT adopt adopt JOT JWT is kind of format. So however, it add 2 additional claims. One is the user, like the other one, user we give it the claim ID is UPN. The other one is the groups. So it's which groups this user belong to. So once you use MicroProfile JWT and when microservice A call into microservice B, it can transfer that JWT token from A to B. That token contains which user you are and what kind of group do you belong to. In B, how can I secure it? In B, I just use Java EE security or Jakarta EE security, like rules allowed. So in this operation, And then it says only admin or user allowed to access this this method. So in this case, like when A pass in like the token, and B can open up that token to say, okay, you are Emily, you belong to admin, yeah, you can access this. And if we send another token, say Bruno, and Bruno is a super user, is not allowed to access this get property for host. So you will say rows are not allowed, etc. So this is MicroProfile GWT. So the next one is how can you build a resilient microservice? So basically your microservice be able to function whatever the situation is. So MicroProfile fault tolerance is here to help you. Fault tolerance actually was influenced by historics and also by failsafe. And it offers a few annotations like a retry, circuit breaker, bulkhead, timeout, all these kind of concepts, pretty well-known concept. The other one is a fallback. So the fallback is very useful. Whatever, if someone saying, okay, I use a history, Istio has a fault tolerance capability as well. However, Istio lacking is fallback. Why is that? It's because fallback needs business logic. Istio is kind of outside this microservice. It doesn't know how to fall back. So this is a MicroProfile fault tolerance, provide this fallback. For example, here, what does this fallback do? Basically, if it call this operation here, if this operation through any exception, and the fallback will be triggered. So you can even say, okay, which exception you want, I mean, this fallback method to be called. You have a you have fail on, and also you can skip as well. Some exception you may not want to like directly invoke the fallback method, etc. Okay, that's the resilient microservice. Next one, you want to achieve like 12-factor up. One of the factor is saying externalize your configuration. Basically, every time when you change your configuration, you don't want to repackage your microservice and then is redeploy it, and changing a line code and repackage it and redeploy it. This is not how microservices should behave. Your microservice configuration should always external to your microservices, and the config should be done outside. It's either in the cloud infrastructure or in the database, and etc. So that's why the MicroProfile config is here to help. So in a MicroProfile config, basically you can use the annotation like a config property, directly inject any config property into your Java classes. In this here means, okay, I inject in maintenance this property into my variable in maintenance. This in maintenance could be specified, declared anywhere. And in MicroProfile config, like a 3 default location, one is in the your application under metainf MicroProfile-config.properties, or you could in the environment variables or system properties, or you can specify any custom config source. You can plug in any, or like a zookeeper, any database, and etc. You can all feed the configuration into your application. And the other thing is, as you know, there's multiple config sources. And then in this way, in this sense, you will need to order them, right? You need to you need to layer them up. We have the concept of config ordinal. Basically, each config source will be assigned with the config ordinal. If you declare the customer config source, you will have to say, okay, what's your config ordinal? And for the default ones, like this default ordinal is 400 system like property, environment variable 300, and microprofile dash config property is 100. So if the same property, like in maintenance, declared in all of this, like this is 100, 150, 300, and 400. The one declared in the system property will be used. All the others will be overridden. So basically, that's what is how it works. So in this scenario here, because in maintenance is defined in here, this microprofile dash config properties also defined in the customer config source is ordinary 150. So this one will be used. So it's true will be injected into this variable in maintenance. So the next, I think that's all about this like microprofile specifications and like how to fulfill this like quality of services. Next, let's have a look like microservice interaction with the cloud infrastructure. So it's when you deploy your microservice in the cloud, you need to monitor like the performance. And also you need to like debug a problem if there's a problem occurs. And also you need to know the health status of your microservice. So the first one in the microprofile like health is able to plug in your microservice with cloud infrastructure, such as Kubernetes. If you know Kubernetes has two props. One is readiness, one is liveness. Basically, Kubernetes treats all these black box, all the microservices as black box. However, there's two entries. One is constantly, because it doesn't know how what your microservice is doing. However, it's from time to time, very frequently, it will knock on your microservice door and say, are you ready? Are you ready to serve request? And then microservice has to answer yes. If you answer yes, it will route a request into your microservice. And then it also knock on the door to say, are you still alive? And then if it's no responses for some time, if it's died, right? If it died, you cannot get a response. And then it's timed out, you get get 500. And then it will automatically kill this port and stand up a new one. And in order to work with cloud infrastructure such as Kubernetes, microprofile health has two annotations. One is readiness, one is liveness. So you directly say, okay, this at readiness, you can have this health check procedure. So under what kind of circumstances, you will say this is ready. If you have a database, and here the logic will be whether like your database is contactable. If it is, yeah, your microservice is up running, you can serve a request, etc. And for liveness, and once the popular logic would be, you can nearly route memory and etc. Probably in that case, you had better to say, okay, please recycle me. Remember here, the format is in JSON as well. So you can hear with this readiness, and then you have the endpoint /health/ready, and then it will work out these procedures and work out whether it's up or down, and then it's feed into Kubernetes. So it's, the next one is MicroProfile metrics. So it's the MicroProfile metrics is here to help you to expose application-based metrics data. Actually, the MicroProfile metrics auto box will give you a lot of base metrics. Basically, the vendor of the implementation of the MicroProfile metrics provide some base metrics, vendor metrics, and then also application metrics. The base metrics, for example, like class loading and etc., and garbage collector. For the application metrics, we will here the example at time. So means okay, how quickly this get operation can return a response and etc. So it has a time, the countage, and gauge, all these kind of annotations. You can check it out. So this one is MicroProfile metrics that is kind of based on the job wizard. So if you know job wizard, so you will know the MicroProfile metrics quite well. It's very easy, very similar. And it has the endpoint slash metrics endpoint. So you can see all the metrics there. So it's if you know the Grafana or Prometheus, and all this information can automatically feed into Prometheus Grafana, can generate some graph for you. So the next one is MicroProfile Open Tracing. For this MicroProfile Open Tracing is here to help you with the scenario, like you have a lot of microservices, like for example, 5. This is a very small number. And then they're all involved in the kind of invocation chain. And then one day you got like a timeout with this, or got a failure. And then you need to debug with the problem. And then you really want to know from the first request, when the user click click the button, and then to the end. I mean, how many microservices involved, and in what kind of time period. So this is the kind of the MicroProfile Open Tracing is here to collate, to like join up all the invocation together, build you a kind of one single chain, one single span. So basically we will say, okay, at this time is was in the microservice A, the other time is in the microservice B, and etc. And the beauty with this is if you are using JXS, all the JXS method automatically traced by default. You don't need to do anything, it's automatically traced. If you want to add a special additional thing to be traced, you can do a add traced annotation, any method you want to be traced, like this. So this is the MicroProfile Open Tracing. Is based on the Open Tracing standard. However, if you know the tracing nowadays under CNCF is the Open Telemetry project was set up. So it's kind of, it was a merged open open sensors and also Open Telemetry. So it's basically is the kind of, this is the new specification is open tracing and open sensors. So it's basically the new open telemetry under CNCF is a new new direction for the tracing aspect for microservices. So you can check it out, check out our project. And also MicroProfile Open Tracing project is involving into that project and then trying to adopt that initiative, or once this Open Telemetry is released, and we want to adopt that into the MicroProfile community. So the next one. How can we, I have talked a lot, so far is about all these kind of all the MicroProfile specifications and etc. And you are wondering how to get started. How can I use MicroProfile? So let me spend a few minutes, give you a quick demo about this. How can you get started? Let me stop. Okay, so it's before I go to the demo, I want to ask you, can you put on the chat, in which area you would like to know more, and etc. And also is the kind of do you feel, do you like, in what kind of things do you would like to see in the demo as well? Or you can come out like a mute to ask questions. Are there any questions?
Yeah, there is one from Will that was asking if it is possible to monitor config value for changes at runtime. Is it possible?
Or is it possible to monitor the change value, change value, configure change value? At the moment, is no. So config is quite interesting. So we have the concept about how to load the dynamic configure property. Like if you know CDI is static. If you want to get the dynamic value, you will need to inject at a provider, and then specify the type. When you do config.get value, you always get up-to-date one. So the runtime is automatically go to your backend to retrieve the up-to-date value. However, there's no facility for you to say when this config has changed, and etc. So if you have any use case and etc., please log on to the microprofile-config to open an issue, and we can look into it. Okay, let me show you the let me show you the starter. So it's this is a microprofile starter. So basically, this help you to create your microservices using microprofile. Here, artifact ID. I can see London Java community, something like that. And then you can see is which microprofile version you want to use. In here, you can see it's normally I use the latest. And then if you are not sure, and you can click on the the microprofile for that entry and take you here, and then you can see the specification. You can also see what's in that in this kind of microprofile 3.3. So I personally involved significantly in this microprofile starter. Again, if you have any questions, and please click on the button, see the code, and then can log some issue there as well. In here, once you choose a version, and then you can find out how many the implementations supporting that version. So I work on at the moment, for instance, there's 5. So it's I will choose Open Liberty, which is one. And then Open Liberty support both Java 8 or Java 11. You can, if you want to use Java 11, you can specify Java 11 there. And then you can select all. So it's all the specifications are going to be demonstrated. So, and then you can just click download, it will be downloaded. So it's, and then you can see all 2 microservices is because you want to demonstrate the client. So so the service A is a client and service B is the backend. So this is all the source generated. However, in order to save time, I already have the app generated directly from the starter. So let me directly show you. So this is generated. This is kind of the code. I just demonstrate quickly to you. So so it's the first thing I want to demonstrate is the how you connect from the client to server. So basically, in the client, you directly say, okay, I know the server interface, which is do something. Let me go to the the server. Yes. Okay, so this is, for example, this is kind of the server. So this is server is actually on Quarkus. So this is on Quarkus. So this is the server as a operation do something, and then it has a path prom and etc. And then in the client, let me see. So in the client, you can just directly declare the interface, like you can call whatever here. And then the most important is a get operation and also do something. And then it's annotated with register REST client. And then you can directly inject your JAX resource. So inject REST client, and then you can call this one. So it's this is how to connect it, and then is how do I wire the client to the server. So basically, in here, so there's a service. So this is fully qualified class name, example liberty or client dot service, and then /mprest/url. So the backend is on the 8080 client service. Let me show you here. So in the Quarkus, so it's in here. So it says 8080. So basically, the service live on 8080. So that don't worry about the error. The error is kind of purposely put the error in there. Make it bigger. So this is kind of that. Let's have a look at the endpoint. So at the moment, the server the client is up running. So it's right. Let me see localhost. So it's at the moment the client is up running, so it can directly call into the the backend. So let me see the backend. So the thing is that I want to say is kind of the dev mode is this Quarkus, and then you can directly to change it is for example add a Thursday here, and then you can go back here. See, you can see Thursday straight away. So without doing anything with it. So the other thing I want to show you is in the client, in your microservice, you can directly also inject any properties with it. For example, here, let me give you the example here. So for example, you can directly use @inject @config property to inject the value. And then the injected value can be defined in here. So you will get injected value in there. The other thing is the metrics. So the metrics, so as I mentioned earlier, you have all the different annotations at a metric and at a time and etc. So you can easily to figure out for example, this is timed. So how much time it take for this operation? The resilience, you can see the, like, you can say, oh, okay, you want to time out this operation. And then if something wrong and you want to fall back to a particular operation. So this is pretty much I want to show you with this microservice. And then also you have like this liveness check, like you can see this JSON format. And also you have the readiness check. So the other thing is I want to show you is once you have this microservice created and etc., you can deploy to the cloud. Let's go back here. Oh, let's see here is a metrics. So you can see all the metrics. If you in the cloud, so you can see all this. If you plug in Prometheus, Grafana, you can make better use of this one. And also you can see Open API UI. You can see what endpoint has been exposed, etc. And you can either try it out, execute, and then you can see the result. So it's in order to, we have a couple minutes left. So let's go back to the slide again. So hopefully, with that quickly, world of the tour with this kind of application, etc. And then you have some basic idea about cloud native microservices with MicroProfile. And then you can use the starter to create your microservice. And once you download this one, and then you can go to a microservice A, for example, here, because it's on Open Liberty. You can say Maven Liberty dev. You can start that microservice. So I have to kill that one, this one, so that this one can start, because the port has been occupied. So, and then you can directly change your code, and you can see the changes straight away in your server. You don't need to do anything else. So it's you can see here is automatically started. So yeah, automatically started, and then you can see go to any endpoint, like we will see now. Yeah, go to any endpoint, you'll be able to see, because in this one, I got all of them. So you can see the metrics. And then you can see a lot of metrics. And then the fallback, here injection, you can see the injection. Okay, you get the idea now. Let me spend 1 more minute to quickly talk about this cloud. So when we talk about cloud, and first you Dockerize it and then put in Kubernetes, and then you might install to Istio. In Kubernetes, it works very well with MicroProfile Config, because Kubernetes config map can define some property, and then you can define this property, and then you can inject the property into your microservice. For example, define this one is a message, and then you can map that message into environment variable as a greeting, and then in your microservice, you can inject the greeting into a variable. So the next one already demonstrates a readiness probe. You can say /health/ready. Kubernetes can check every 15 minutes, 15 seconds. Oh no, 5 seconds. So the next one is if you use Istio, MicroProfile Open Tracing propagate all the 7 headers required by Istio. So you are safe there. So you don't need Istio at the moment. The documentation saying you have to propagate these 7 headers required by Istio. Once you use MicroProfile, all these headers are propagated. So that's a bigger picture of EC2 and MicroProfile. So you use MicroProfile as a programming model, and then use the EC2 as a infrastructure. They work well together. So this is useful link, so you can check it out. So Open Liberty IO/guides. If you click on it, it has many guides to help you with learn all the MicroProfile technologies. So a lot it only take half an hour each guide, or sometimes only 15 minutes to learn from it. And also I wrote a blog about MicroProfile with EC2. If you are interested, check it out. Okay, that's all from me.
Thanks, Emily. We have some questions from the crowd, if you want to take them.
Yeah.
So the first one would be about the framework, the MicroProfile itself. So is it compile time or a runtime framework? The first question.
Oh yeah, good question. Yes, as a compile time framework. Basically, it's like it offers a lot of APIs. If you know Java EE, Jakarta EE, so similar to Java EE, Jakarta EE, MicroProfile give you a lot of APIs, annotations for you to use.
Mm-hmm.
And
so,
yeah, go for it.
Yeah. And there's also the question of, does it support Kotlin? Do they have Kotlin bindings? So can we use Kotlin with this?
That's a good question. At the moment, is no, is Java, is kind of Java based. We might look at the Kotlin support as well, but at the moment is Java.
Okay, and again, talking about the difference between Spring Boot, which I think is a big competitor here, no?
Yeah.
And I was asked, what is what's different from Spring Boot compared to this? Well, what's the advantage of using this versus Spring Boot?
That's a very good question. I did a talk about compare Spring and MicroProfile, and you can get it from YouTube. And also, I wrote a blog, Spring and MicroProfile.
Maybe you can put it on the chat so that people that
let me put on the chat here. Put to the chat here. Yeah, I wrote a blog last year, and I directly compared the side by side between Spring and MicroProfile. They are very comparable. So there's a company who was a Spring shop. So they used the Spring before, and then they migrated to MicroProfile. They said they reduced 30% of the code. So basically, MicroProfile much simpler.
Okay, there was also a question in regards to Micronaut.
Yeah, Micronaut does not support MicroProfile. Quarkus does. So it's Quarkus adopts MicroProfile, and however, Micronaut is kind of similar to Spring. So they have their own set of APIs.
Okay, and how would you compare MicroProfile? I mean, a MicroProfile implementation to Micronaut, if you were.
Oh, okay. So actually, it's, this is if you if you know Adam Bain, I think he talked a lot about MicroProfile and Quarkus and Spring, because the Micronaut and Spring have their own set of APIs. It's not portable. So you have to, if you choose Micronaut, you are Micronaut forever. If you choose MicroProfile, you can switch. Like one day you use Wildfly, and the other day you use Open Liberty, or you deploy to Quarkus. So this is
that's exactly as I said as well, because MicroProfile is also specification. So you code against the specification, and then you can swap the implementation, right?
Yes, yeah, exactly.
Okay.
We only have set of the yeah, APIs. There's another question: does MicroProfile framework offer anything for microservice contract testing? No, MicroProfile framework at the moment doesn't do testing. However, there's kind of container tester containers. For example, there's another open source project called MicroShed. So it it has a MicroProfile integration with tester containers. So you can check it out. So it's for the container testing.
Okay, there's one last.
Sorry,
go ahead.
That was the question from me. Thanks, Emily, for the presentation first. Sorry to interrupt. It wasn't about the container testing. It was more about contract testing. So you've got a consumer-driven contract testing that you can do, for example, with packs or with even a Spring Boot cloud. So I was wondering whether MicroProfile offers anything similar.
Oh, I see. The contract testing. No, MicroProfile has not entered the testing. Area. No, I think it's the pretty much the testing framework MicroProfile adopt and trying to promote is kind of Aquilian based.
Okay, thank you for clarification.
Yeah, you're welcome. So we did talk about whether MicroProfile should also offer some testing. There's different views on this, and eventually have not settled. So on what kind of testing framework MicroProfile should come up with.
There's a last question about two questions actually. Any parallel spec to Spring Actuator apart from the health?
Oh yeah, it's a Spring Actuator. It has health and metrics, and MicroProfile has a MicroProfile health and a MicroProfile metrics. Yeah, so that's the kind of comparison. I'm not sure which Spring Actuator details you are thinking of. So you can come unmute and talk.
Yeah. Wait.
Yes, actually the matrix bit also. So yeah, there was also that spec. Yeah, so I was mainly talking about the gathering the matrix apart from the liveness and readiness check. So yeah, you also mentioned about that matrix part. So you basically it's split kind of into spec.
Yes. Yeah.
Right.
Exactly.
Yeah. So,
yeah. So in my blog, basically I have actually I'm at in my blog already compared actuator and with health and also with metrics. Let me quickly show you something. Let me go to this line. Since you are asking this, let me share my screen with yeah. So this is a comparison. Yeah. Can you see my screen?
Yes, we can see it.
Yeah. Actually, I'm just taking a screenshot of it. Yeah. Okay. Yeah, I'll have a look. Yes. Thanks.
Okay. Thank you.
So there's one classic question at the end. I think it's the last one, which is the final question that we all, I always have this question all the time. So what's the best JVM, but in this case for microservices? So OpenJ9, Grau, VM, or something else?
Oh yeah, this is a very good question. GraalVM is basically the offers trying to offer is offering a language basically is polyglot, is a native mode compilation. OpenJ9 at the moment is more comparable to OpenJDK. So GraalVM is a different category. So it's kind of more like you do hardwire, like remove the reflection at a compile time. Once you compile, you're not allowed to change. So basically, you the JMX is not supported in a GraalVM. Basically, this is one of the disadvantage with the GraalVM. So a lot of the monitoring and etc. is kind of that is not supported in GraalVM, but they are exist in the OpenJDK. So OpenJ9 and comparable to OpenJDK. And there's kind of currently for Java microservices, I think a majority, a lot, I think this, I have not done the survey, however, I listen to others. It's the most of the project, they are on the non-GraalVM path, is because of this kind of like JMX support, and also is if something goes wrong, you want to debug into it, right? And etc. Nowadays, all these kind of runtime are really fast anyway, so people stay put with like either hotspot or OpenJ9. However, OpenJ9 is trying to increase the performance, also looking into this kind of native mode thing. Anyway, they are all in the open source. Yeah.
Okay, I think that's all. I don't see any other question. I think we answered all the questions.
If I can just, yeah, if I just can interrupt. No, I mean, will the slide be available? That's the question. The deck.
Yes, yeah, I can share the slide. So I can give the slide to Bruno.
Mainly for the last links, yeah, okay. I didn't take a screenshot. Mainly the last link was there, so I'm interested for that. So
right.
It's fine if you just also put that.
Yeah, I think that this whole thing is recorded, so it will be available. You just need to ask Barry
okay.
from the communities, from Meet a Mentor, and you can replay it and see it all as many times as you want.
Okay, yeah, that's good.
Let me share the last slide, so you can also take a screen share.
Yeah.
Okay. Done.
Okay, cool.
Thank you.
Yeah. Thank you all.
Well, thanks again, Emily. It was great to have you and to listen to you again. And thanks to everybody who attended the meeting. And and I hope we see each other very soon outside in the real world.
Yeah, exactly. Actually, the funny enough, this year is on my agenda to say I want to visit the London Java community. Want to do a talk, because last year I supposed to do a talk, it didn't happen. So here we are. So I would like one day we'll do a physical talk at London Java community.
Yeah. Well, we're all looking forward to it. Thanks again for everybody for your time, and have a nice rest of the day, and see you all soon.
Yeah, see you. Bye.